some actions we take. But then the assumption behind game theory is that we always make rational decisions. Kind of take it with a pinch of salt. But in order for us to be able to model something, model anything for that matter, we have assumptions. Any even mathematical models have assumptions behind it. If you do statistical model, assume normal distribution, right? Very conveniently, right? We all do that. Right? Like that, the idea of economic agents is, utility driven. So those agents whose outcomes question might have been, in other words, there are things out of your control, but you still face the consequences, right? A game consists of a set of players or actors, a set of moves or strategies available to those players, and the specification of payoffs for each combination of strategies. We use game theory to model knowledge exchange decisions under risk in a supply chain of that. That's where we're going. So, game theory is a theory of interdependent decision making. Game theory has been used to model auction and bidding behaviors, cartels and collusions, job market signaling, market pricing behaviors, negotiations very much, arms control, nuclear deterrence, joint ventures by paper by parquet, market entry and deterrence. See, I'm trying to point out some of the domains. One of you asked me about, how about in marketing, this morning. So these are knowledge exchange behavior, which is what we are trying to do. And the popular research domains are economics, political science, management, and information systems. These are the popular areas. Okay, the fundamental assumptions of game theory is rationality. Actors are rational. Goal maximizing behavior. No sentimentality or other non-utility consideration. Right? These are the premise. If you reject these assumptions, then game theory is not for you to use. Right? Under these assumptions, game theory is powerful. All goal attributes are represented by utility values or payoffs for an actor. There is no intransitivity in preferences. That essentially means if A is greater than B and B is greater than C, then transitively A is greater than C. Holds. Okay. So, to tell you the truth, there are lots of rational decisions we all make too. It's not as if, all the time we are working under bounded rationality. There are situations where you do rationalizations. So, modeling in game theory, there are two ways we can go about it. One is called extensive form. It's kind of a graphical representation of players and the moves. It's called the full information model, and sometimes it's less convenient to do analysis with. So we have the other model called the normal form, so a strategic model, which is kind of a matrix representation where we can do actually the computations. But this is less informative. Okay, so we use both kind of to be able to explain things to people and then solve the problem. Okay, here is a quick example introducing the extensive form of game. Here is a situation where there are two players, Guy and Viveka. The actions Guy takes is, Guy has to decide